So remember, molarity is our main unit of concentration within Chem 1 and in AP Chem as well. There are actually other units of concentration that our textbook will refer to. However, we don't have to know those anymore. So percent by mass, we don't have to really know about. Molality, we don't have to as well. Moles of solute per liter of solution. Now again, the equation that you'll be given is molarity equals N, which is moles of solute divided by liters of solution. But some students from Chem 1 like that triangle that we give you, where you have molarity, moles, and liters. You cover up what you want to solve for. It shows you how to solve for it. So if you want to solve for molarity, it's moles over liters. If you want to solve for moles, it's molarity times liters. If you want to solve for liters, it's moles over molarity. So maybe that little triangle will help some of you out. Recall metric conversions. Again, typically we measure volume in milliliters. However, molarity has to be in liters. And then lastly, let's remember from the last unit that we did, very common that solving for moles of solute is nice. However, we're typically going to have to get to grams using our periodic table. A couple other things to recall when we're dealing with molarity is the volume is not the volume of water alone, it's the volume of water with the solute. That's why it's liters of solution. However, the moles of solute, the solute is kind of that active ingredient. So for example, we have a solution on the trays for next class. It's 6.0 molar HCl. So that's the molarity of the hydrochloric acid solution that you're going to be working with. So for every 1 liter of solution, there's 6 moles of HCl in it. Now, I have on my next slide a couple of practice problems that we're not going to actually solve, because I think you guys, if I just give you a sheet with practice problems, you can kind of roll with that to a certain extent. So I don't think you have to worry about solving either of these. However, like in the second one here, I could give you the grams of a substance, and I could give you the volume. Remember, with molarity, take the grams of the substance and convert it into moles. And that's kind of your when in doubt, find a way to convert to moles in this class is usually a good rule of thumb. But once you have moles, you could then convert your volume into liters pretty easily. Moles divided by liter would get you to the molarity in that one. Okay. I want to add on to molarity, however, and that is with something called dilution. To dilute means to water down. And as we get further into this unit with some of the labs that we're going to be doing, we are going to be diluting things. As a matter of fact, I think I'm going to have you practice diluting next class. I kind of like this starting up and about. I think I want to do that next class period as well. Is we're going to start up and about with something simple but learn a new technique. So when you add water, you make it less concentrated. My second bullet point here is actually something from the safety contract, that if you have a concentrated acid, you shouldn't add water to it to dilute it because it will boil the acid, and boiling acid's bad. Instead, you have to add the acid to the water. You do it as your honor, you add acid to water. It rhymes, it must be true. Third bullet point is important to think about. That when you dilute something, you are not changing the amount of solute, the quote-unquote active ingredient. All you're doing is taking that amount and putting it into a greater volume. Now, mathematically, our equation for dilution is M1V1 equals M2V2. Which is not given to you, but dilution is a pretty common thing. In fact, me and Ms. Kirk are talking every now and then because of AP Bio, they have to use chemicals for a fair amount of things. And she has to know that equation when she's doing stuff in AP Bio. So what I'd like to do is one dilution practice problem with you to start off, because that's a little bit newer of math. Molarity, I'm hoping that you look at practice problems, it'll come back to you. Dilution's a little bit new, so that's why I want to do one problem of that with you. And then let's give you time to work on both of these to remind yourselves how to do it. So, you picked up on the way in a sheet that says the how-to of diluting calculations. You can have that out. We're going to do one question on there to kind of wrap up our notes for today. So on the top of that sheet, I run down an explanation of dilution. I'm going to do example number 1 with you right now. Example number 1 says if you want to create a 1.00 liter of 0.50 molar HCl, how much 12 molar HCl would you need to dilute? Again, if you see the word dilution involved in the question, you need to realize this is what we're going to be working with. And I guess one of the things that's nice about the gas laws is we've done now these 1 versus 2 mathematical equations. All you have to do is keep track of the data. So if I again read the beginning of it, it says, if you want to create a 1.0 liter of a 0.5 molar solution, 0.50 molar is my molarity, and 1.0 liter is my volume. How much of the 12.0 molar HCl would you need? 12.0 molar is given to me. I need to solve for V2. Again, algebraically, that's simple enough for you guys. If it was in liters, I'd get 0.042 if I did 2 sig digs. Or 1.7 if I did 3 sig digs. This would be liters, which is the same as 42 milliliters. Now, most students have no problem with that bit of math. And you guys are good at math. This is algebra. This is just keep track of variables and now solve. However, they struggle with what does that mean? That means if I wanted to make 1 liter of solution, again, 1 liter of solution would be this much solution. What I would do is I would take 42 milliliters of the acid, and the rest of it has to be water. We're watering it down. And we have to be able to make solutions in this class. So a lot of people get to this point and then they think, what do I do now? How do I physically make the solution? We're going to practice this at the start of the next class period. We're going to show you a couple of new tools that you can use to make the solution with. But again, you are solving for the amount of the concentrated stuff. The volume is going to be bigger when you're done because we're watering it down. So we use distilled water to dilute when we're doing it. So my hope is today we introduce the math for both of these molarity things, just regular molarity and dilution. Next class we'll practice it a little bit leading up into the lab because next week in particular we're going to be using it a fair amount.